Hi and welcome back. So let's try another example. And in the past video we were figuring out electronic geometry, molecular geometry, the ideal bond angle, and also the deviations from the ideal bond angle for a given molecule. So let's just do another example with that. So what we're going to try to figure out, and if you want to, and as usual, I would recommend you listen until I state the problem, and then you pause the video, and then try to do the problem yourself. And then once you've figured out your answer to the problem, unpause it and just see if we both got the same answer. So now let's try another element. Let's try doing this with SBr2. So this is going to be sulfur dibromide. So let's figure out what this is going to look like. Bromine, let's figure out, first draw our structure. We have got sulfur, which is going to be our central atom. And how many valence electrons is sulfur going to have? It's going to have 6. And then we've also got 2 bromine atoms. So bromine is going to be down here. And bromine is going to have 7 valence electrons. So let's just start drawing the structure. Sulfur would go in the middle. And what is the valence electron configuration of sulfur going to be? Because remember, we start out with I guess it would be our 3s electrons, and they start out being paired. And then we start grouping together the electrons in our 3p orbital. So we start out, the way we fill our valence shell would be 1, 1, 2, then 3, 4, 5, 6. So this is what our electronic configuration is going to look like around our sulfur. And then we're going to be bonded with 2 bromine atoms. So the bromine will be right here, and we can start drawing the bromine electronic structure too, like that. Br, R. So this is what the electronic structure is going to look like, and you can see where our bonds are going to form. And this is going to form, so the bond is going to look like this, and we are going to have 2 lone pairs around our sulfur atom. And so now you can count and you can see that the formal charge on each of these atoms is on all of these atoms is going to be 0, because we've got 1, 2, 3, 4, 5, 6 electrons around our sulfur. And then we've also got 7 electrons around our bromine atoms. So I'll just go ahead and draw those in down here. And so now on this molecule, what is our electronic geometry? So electronic geometry going to be? Well, how many electron groups do we have around our sulfur? We've got 4 of them, right? So we've got 4 electron groups, so that means we are going to have tetrahedral electronic geometry. And then what's our molecular geometry going to be? So molecular geometry. And we've got 4 electron groups, but we've only got 2 bonds. So we've got 4 electron groups and 2 lone pairs. So our molecular geometry is going to be bent. And you can represent this molecular geometry in 2 dimensions. So this is, I don't need to draw one molecule going back into the board or anything like that. You can represent a bent molecule in 2 dimensions. So now let's figure out what is our ideal bond angle. So the ideal angle, and that's going to be, we've got tetrahedral electronic geometry, which means that the ideal bond angle between these 2 bonds is going to be what? It's going to be 109.5 degrees, right? Because that's what the bond angle is in a tetrahedral structure. And in actuality, if we observe this molecule in nature, what is this bond angle going to be? A little bit more than 109.5, or is it going to be a little bit less? Well, it's going to be less, right? So the actual, I'll call this the actual angle, is going to be, this is going to look weird, it's going to look less than 109.5 degrees. And hopefully you can see that this, I should probably figure out a better symbol to draw, but I'm saying the actual angle is less than 109.5 degrees. And why is that? It's because we've got our lone pairs of electrons up here. And these lone pairs are going to be more repulsive for these atoms. So they're going to get pushed closer together. These electrons are going to repel these atoms a little bit more. And so therefore, these two bonds will just become a little bit closer together. So our actual angle is going to be a little bit less than 109.5 degrees. So there we go. That's our example. We have tetrahedral electronic geometry, bent molecular geometry. Our ideal angle is 109.5 degrees, and the actual bond angle is going to be a little bit less than that. So anyway, thanks for watching, and I'll see you in a future video.